Okay, go ahead and get out your scratch paper. If you don't have any, make sure you get some before you start. You can pause the video and get some more scratch paper and go ahead and follow along with the math on the spot.
You know, it's great to learn from mistakes. So actually, I asked my friend Emilio to make a classic mistake involving finding surface area so that we can actually learn something from Emilio. He agreed, and here is his story, and here is his work. And let's see if we can find that deliberate mistake in order for us to learn a lesson. Here we go. So Emilio is designing the packaging for a new MP3 player. Now, the box for the MP3 player is 5 centimeters by 3 centimeters by 2 centimeters. Emilio needs to find the surface area of the box. Now, look how Emilio answered the question, and let's see if we can find his error, see if we can correct it, and then actually find the surface area of this rectangular prism. Well, here is the net, meaning here is the schematic that we would take and then fold up in order to make the box that would have dimensions 5 centimeters by 3 by 2. And check it out. You can see it for yourself. Here's the 5 centimeters. Here's the 3 centimeters. And here's the 2 centimeters. So when you fold up all these pieces, we should be able to, in fact, get the box. And so what he did was he quickly found the area of each of these rectangles and add them up, because surface area just means the area of all the surfaces of a particular solid. And so in this case, they're all just rectangles. That's the face of every single part of the box is a rectangle. So face A, notice, is 3 by 2. So 3 times 2 is 6. These are all centimeters squared. B is 5 by 3. 5 times 3, or 3 times 5, is 15, so that's good. C rather, is the same thing as A, and so we see 3 times 2, which is 6. And by the way, you can even count and see the area. 1, 2, 3, 4, 5, 6. So that actually is representing the area, 6. D is going to be 3 by 5. And 3 by 5 is 15, so the area is 15. And E, 3 by 5. F, 3 by 5. And you add up all these numbers. 6 plus 15 plus 6 plus 15 and 15 and 15 is 72 centimeters squared. This seems perfect. But Emilio is trying to teach us something. And what he's trying to teach us is we have to be careful if we know the dimensions are 5 by 3 by 2 and we create our net. Because I've actually created this net, and you can see it for yourself. You see how I created that exact same net? You can see it. And check it out. Here's the 3, the 3, the 3, the 2, the 5. And now let's try to make the box. So if we try to make the box, look what happens. There's the box part. But look, when I turn this up, it doesn't quite fit to the top. And if you look now visually at this part right here, you can see the problem. The problem is that this is length 2, this is length 3, and you see they don't fit together. They don't fit together. So in fact, if you want to make a 5 by 3 by 2 box or rectangular prism, in fact, this width here has to match up to this length right here. So this actually has to be a 2. And if you think about it, this would have to be a 2, then we'd need a 3 for up here, then we need another 2 here, so we need another 2 down here. So in fact, this configuration is not the right net for this box. Very interesting. The right configuration would look a little different. It would actually look like this. Check this out. It's difficult to visualize things when you actually have them be three-dimensional. But in fact, this is the right one, and let's see if we can see it for ourselves. Because when we fold this up, this would be 2 up. And then this, when we fold this up, would be 2 up. So they'd match up perfectly. Then this 3, if you imagine pulling up that 3 right there, that 3 would match up with that 3, which would be the lid. And then that lower 2 would be this 2 here. let me show it to you because I've actually made this as well. Here's this model. So here's the second model. And now check out what happens. Look how nicely everything folds in. This folds up, and this folds up, and they meet perfectly now. And now that 3 here is, in fact, this 3 right here. And that 2 right here is this 2 right here. And you put it all together, and look, we have produced a rectangular prism, or a box, that is 5 by 3 by 2. Isn't that neat? So when you unfold it, this, in fact, is the correct net for that. And so it's very sneaky. You have to be really kind of visually, artistically apt. So let's see what we have to change here. So the A is the same, so that's good. So in fact, we like that, so that's all good. The B is the same, that's good. The C is the same, that's good. Now the D is different. This is a narrower D. This is actually 2 centimeters by 5. So in fact, what we want to do here is take away D, that's just not good, and we want to replace it by 2 by 5, which equals 10 centimeters squared. And so now, in fact, that's good. The E face stays the same because that's going to be the same as the B face, the top face. You see the opposite faces. B and E have to be opposite, and then the F and the D are going to be opposite each other. So that means that, in fact, the F is wrong, and the F is now going to be, in fact, the same as the D face, which is 2 times 5 in area, which is 10 centimeters squared. And now, in fact, everything is correct. And if we add up these numbers, remember this was a 15 before and a 15 before, so in fact we had 10 too much, and so this answer actually is wrong. If you add all these up, what we now see is 62 centimeters squared, and that actually is the correct answer. So the actual surface area of this rectangular prism is, in fact, 62 centimeters squared. So it's interesting to realize that even though you would create something that would first appear to be perfect, once you start to think about it carefully, you realize that opposite faces have to have the same dimensions. That's the key. But when you take opposite faces and you create a net, it turns out that those faces actually are going to be kind of not next to each other. You have to visualize the folding. Visualizing the folding is really what life's all about, because what first seems to be obvious often might not be quite correct. But once we make meaning of it and think through the act of putting the pieces together, everything fits perfectly. Have fun looking at the nets in your life, folding them, and making beautiful rectangular prisms. I'll see you soon.
Thanks for watching, and I'll see you on the next one.